I'm okay.
Okay.
Okay. So just a couple of quick ground rules here. So David sent me a list of what I think are very good questions that lots of people are likely to be worrying about implementation details. And so I think that's a good place to start the discussion. But in this case, I would really invite people to interrupt and ask questions as I go along. If you're online, the easiest way to do that is by raising your hand, because I'll be able to see that. If you're in the uh, in-person group there, you'll just have to yell into the microphone, and I can hear it. But it's really important that you not have multiple people yelling into the microphone at the same time, because I can't hear, as you may know, it just gets incomprehensible. So, okay, so with that, I'm just going to start out. So his first question is there a place for lecturing with this approach, and is it different for introductory, intermediate, and advanced courses? So like I say, this is really an excellent question, because people can easily get confused in in this and how to implement it. And so this depends a lot on what you mean by lecture. And so you really have to look at the nuances of that. So if you define a lecture to be, an instructor comes in with a set of pre-prepared, notes and information or PowerPoint slides, and just goes through that, where the students are spending almost all their time just listening. There may be, I've looked at Stanford courses, there may be 1 or 2 questions asked by students during the hour, but that's about all. So if that's what you mean by lecture, the answer is there's really no place for it or no use for it, except for when I talked about my talk yesterday being more a sermon than a lecture. And by that, I mean, an inspiring story that makes the learners want to go out and learn more about the subject, or run off and become physicists. That's a whole separate thing, but that's not really much learning. That's just kind of the inspiration. If it's a really just transfer of information, you should get rid of that. But that doesn't mean that the instructor shouldn't spend time talking. And I really emphasize this. And there's actually a classic paper by 2 of the most famous cognitive psychologists who look at education, called A Time for Telling. And what they show, and this is really the lesson you want to take away from this, is that when the students are prepared to learn from the telling, then telling's very effective. But it's the preparation to learn from it that's critical. And so in the kinds of things I'm talking about, in the orchestration of these classes, the instructor should be talking a reasonable amount, like 40 or 50% of the time. When we've seen the best classes, are the instructor talking, but they're not doing it in terms of just giving prepared information. They're having the students first be prepared to learn from that talking by working on problems, talking with each other, understanding what that they need things to solve it, and they recognize particular challenges that the instructor is then knows what they're thinking, and then is talking in the form of targeted feedback on what they need to learn, what they've been prepared to learn. And so that kind of instructor talking is really critical. And I stress that because we sometimes see people read about this and say, oh, I should just turn it over to students doing everything, working with each other. And that's absolutely wrong. You need to take advantage of the expertise of the instructor and just deliver it at the right time when the students are prepared to learn from it. So does that is there, I guess, Alan, did you have a further question on this?
Yeah. So I'm doing a flipped course. I flipped my course a few years ago, and the group work part just doesn't work well. So after listening to you and thinking about it, I was thinking of mixing the two, right? Keep the flipped part and that my lectures are all, few minute segments and so on when they don't get to class. And then in class, instead of what I'm doing now, trying to do more the approach you're talking about. So is that sort of mixing of lecture and what you're talking about? Do you think that would work or no?
I don't think it's particularly effective. I mean, there's been very little studies of the kind of value of having a lecture before, more traditional lecture before class. What there is doesn't say it should be any better than as the ineffectiveness we learn in class. And I think there's actually reasons to expect it's going to be less effective, and that has to do with the level of distractions that people have when they're listening to an online lecture, or even greater than when they're coming to class. So, what I would do is I'd go back and look at your group work and see how, think hard, and you can go to our website on this, where I'm gonna share my screen just to give you, let's see, do I have?
Alan, you have to authorize that.
Okay, let me hunt for it. I don't know how I became the person to lead this, but
you go down the bottom of the green one.
Got it.
There. Perfect.
So if you go to this UBC website where we have this, and then you go under guides and resources, particularly under instructor resources, have a whole bunch of things about material for prepared students for class, optimizing group work, and where these are like, I try to give them 2 pages to all the details. And so my first thing or first response to you would be, there's I make it sound easy because I'm rushing through it in a talk. There's 6 or 7 things that seem like details, not so intuitive, but pretty darn critical to making group work effectively, that we see people easily overlook. So I would sort of focus on that particularly, but I'll say a little more about the preparation for class, because I think some people think, well, they'll just give the regular lecture and expect students to learn a lot from that. And that's really not kind of fair. I mean, it's just one step harder than being in the room with a lecturer, where we know students, it's just way too much information. They're not processing properly. So they're not learning that much there, but at least they can ask other students or questions in that setting, and they can't do that in watching an online lecture. So I think there's pretty good reasons for not. Now and we do have some studies that have compared just reading material, and because the preparation for class that I think is important is just think about what you don't really need to have in class, what students can get. So, terminology, basic information, description of important experiments that are done. And so they can just get that as well from reading, in fact, better from reading, because they can do it at their own pace, and they can look back at other chapters in the book. They can get that better from reading than you can from a lecture. And when we did equivalent comparisons, we found, the reading, students learned as much from it, but they did it much more quickly than they got from the lecture. Now, the exception to that is when you don't have good readings. I mean, maybe especially if you're doing some specialty course, it's your stuff, then okay, it's usually a lot easier to just give a quick recorded lecture and have them do that. What I will say, and we studied this too, is how to get students to do it and do it effectively. And we do have a guide on that here. And because people complain, somebody, I'm getting feedback. Okay. People say, oh, I tell my students to do reading and they never do it. And that's pretty typical. And so we did experiments until we found we can get 85% consistently over a whole bunch of different courses of the students to do the reading. Interestingly enough, it's not the same 85%, which is what I expected. Which 15% aren't doing it varies. But here are the clear steps to doing that reading. So first, it shouldn't be terribly long, 15 minutes to half an hour is really all you're going to expect. So it should be quite targeted. And what that means is it shouldn't be chapter 2 of the textbook, because textbooks weren't written for teaching. They were written to sell textbooks. And that means they have to include every item that every teacher who might buy the textbook wants included. And so they're really bloated. And so you really need to go in there and pick the particular sections that you really care about them looking at carefully. And then you also need to have some sort of check and reward for doing it. So we find a, really simple online quiz, 3 questions are really effective, and, it's automatically graded, or you only just give credit for them. You don't have to worry about it. But you can also make those questions particularly helpful to guide their reading, like in the curve in figure 6.3, demonstrated what, and then they've got a multiple choice answers there. So they really paid attention to that curve. So, and then the final thing that's the most important about getting students to do the preparation before class, whether it's reading or listening to your short lectures, is to not, this is what you should never do, but so many instructors I've seen do it. They come into class and say, well, you were all supposed to do the reading, but I know a bunch of you didn't do it. So here I'm going to tell you what was in the reading, okay? And so what that's just done is it's punished all the people who took the time to do the reading, and it's rewarded all the people who didn't take that time. And students are very, like everybody, very concerned about their use of time. So you do that once and you'll never have them do the reading again. So, okay, so that's really long-winded answer about, I think, let me just see my notes to David's question about the reason about lecture and the value of it. Yeah, so I just want to emphasize.
Alan, as a parent, I screwed this up. Since you're now the host, can you move the picture so we can see Carl on the top better? Maybe.
He's sharing the screen.
But usually you can put it. Well, anyway, if it's not.
This is the local session.
Yeah, that's from us.
I think that's something you do locally.
Cool. Yeah.
Oh, okay, sorry. So we can. Oh, okay. Excuse me for interrupting. This computer. Go ahead, Carl.
Okay. Yeah, so important thing about it is important to tell it, that part about telling. The second part of that question was, is it different for at different level courses? And this is an area where there's much less work than others. But it's mostly been done by my group. And so I think I can say with a fair amount of authority that the particular activities that you're having the people do, that of course is quite dependent on the level. But if you can boil it down to what is the kind of this problem solving decisions you want those students to be learning, and involving the material and the kind of problems you hope them to be solving at their level, and then you really design your activities to do that, to go through that. We find that basic design then maps on, like I say, from first semester physics up through graduate field theory has proven to be quite effective. And in all of those cases, this idea of, well, the instructor their talking is really in response to the prepared, to prepared students, and the roughly 40% of the time, very roughly, it of course varies, is about the same. So I would say that there's no big difference there.
May a follow-up question? So one thing I wanted to also ask about, follow on that, is you had in one of your slides motivation. So why are you learning, right? What is the motivation? Why are you hoping to learn from what we're discussing? I think is really important, right? Because it's not only, I would say, perhaps decisions you make, but why are you learning about the subject? If you know Eric Mazur's work, right, at Harvard and MIT, I think that's also important to keep in mind. What are the preconceptions of students that might have coming in, especially when I teach introductory astronomy to non-majors? That's really important too. What are the kind of preconceptions people have about science and how science works, or the scientific principle, why they're learning. When I say, well, imagine you're Matt Damon and you're sitting on the Martian and you're stuck on Mars, what are the things that are different? I felt, students were much more engaged to then use all the equations I had given them before about, gravitational force inverse square law of light, versus compared to, I say, well, these are the equations. Imagine you have a bigger planet, you have a smaller planet, and so forth. So did you see something similar in some of your work, that the motivation of the students and why they're learning would make a difference?
Yeah, we see motivation, and we've done other studies about student attitudes and motivation. And you actually picked, Eric is a kind of variable, but the MIT is a particularly bad example and one you shouldn't follow, because what we know about, motivation in general, but motivation in learners has been studied quite a lot. And there's a few three basic, really critical principles here. And the first one touches on what you're talking about, is making the material to be learned useful and relevant to the students. And I emphasize to the students, because that means you really have to understand connecting with their experiences. And so, some students may get excited about knowing how the gravity on Mars is different, but there's a lot of students who aren't going to care about that much at all. But maybe they're going to be, care about why the condominium collapsed in Florida and the way gravity pushes on stuff and breaks it. Or something else. And so this issue of understanding your students, but then understanding how to present it in something that's relevant and potentially useful, connecting up with their own lived experiences, connecting up with their future career interests, etc. Now, physics is particularly bad at doing this. If you look at a standard physics book, it's all filled with these, massless blocks on frictionless inclined planes and Atwood's machines and so on, which is, absolutely nobody would ever imagine somebody would care about the answer to that, other than a physics professor wanting to give you a test on it. And so when I go through and look at the homework assignments in normal textbook, and this, because we've studied how students respond to these things, it's really, I just cringe, because they're really pretty terrible from the point of view. And so we have data showing, and we develop tools that other people use, they get the same thing across many different institutions, how taking an introductory physics course for the average student, and there's variations, but the average student actually has less interest in physics at the end of the course than they did at the beginning. And they also have less expert-like attitudes about the value of physics and science, in terms of thinking of physics as not something that explains the world around you and, is determined experiments. Rather, they see it as, stuff you're handed down by some authority, and it's kind of completely meaningless things that are only relevant to the physics classroom. So, so anyway, that's a long-winded but covers a bunch of areas of research that are get to your point of motivation. There's another two aspects, so there's making an interesting and relevant context. There's also making, conveying to them that they can learn physics and how to learn physics. This, we talk about mindset, and it turns out you study students, and there's a lot of them, and frankly, more female than male, who will go into and just think, okay, I just don't have a physics brain. I'm never really going to be able to learn this, or connected with there's, I don't know how to go about learning it. And so those are really critical motivating factors. And those are things that are also, we've researchers shown are quite flexible. But if you just take an active effort as an instructor to convey to the students that, no, you believe they can, everybody can learn this, you know, and you're there to help them learn it, and you pay more attention to really what's involved in more detail about going through the learning process, which I think this is back to the expert blind spot that we talked about yesterday, that as an expert, you've gone through this so much, it's really hard to remember that people are just learning, just don't know how to do the learning. And so that needs to be modeled for them better. So there's one other important thing about motivation that I'm forgetting, but it'll come back to me. But those are the main things. And it is super critical, I have to say, emphasize that to motivation. And it doesn't take that much work, though, to do a much better job than is done in most college courses. Okay, if nobody else is jumping in, I'm going to move to David's next question.
Matt was timidly jumping in.
Well,
Sorry.
I have
Okay.
two questions. But let me, one of them maybe would make sense to ask later because it's about evaluation of teaching. But the other one is relevant to something you were just saying. So in a lot of our courses, we have recitations, which are typically taught by graduate students and are maybe smaller than the lecture, or maybe not. And there's a lot of variability in how those are run, but many of them are similar to the flipped classroom model that you're describing, in the sense that the students have already been exposed to the material through the lecture or through reading or through working on problems. And then they come into the recitation and they discuss problems with each other and with the instructor rather than the instructor lecturing. So I'm wondering how you think that plays into this whole story, where you have a traditional lecture, but you also have weekly recitations that are more or less flipped classrooms.
So the main thing we've seen about recitations is they are incredibly variable. And if you don't have trained teaching assistants, they're probably of very little value. You really have to have the teaching assistants who are trained in the methods that I'm talking about here, where they're encouraging the students to work together, and they're monitoring them and they're giving them very targeted feedback. You know, it is a smaller environment, they can interact more closely, and so they can give more targeted help to students. And in that case, you expect they're going to be valuable. But many times these teaching assistants, particularly when they're not trained, they just go in and they just work through the problems while people watch them, and that's pretty worthless. Now, you know, what I will say is that as we've gotten more, let's say more experienced and refined at teaching this way, and both so this happened in a large number of cases at University of British Columbia. It's now happening in most of the physics majors courses at Stanford, is that we're just eliminating the recitations, actually, because the recitations, they're built on a flawed model of learning, that you that you need to dump this information into the brain, and then the brain goes off and practices problems with it, and it gets better at that. And the research shows, no, that's just wrong. You do vastly more effective if you have them struggle to try and solve the problems, and they get information as they need to solve it. And in some of the references I gave, you can read about that. But in any case, given that, what the model that we're going more and more to is we still have the TA resources, and so we're using them, and in a couple of different ways. One is, and this goes actually to a question David asked about the size of the class, and I'll just cover this, was that we found, and it's not really, hardcore systematic research, but it's kind of collecting reasonable data on what seems to be working. We found that an instructor that knows what they're doing can cover about 40 students pretty well, a class of about 40 students of this, monitoring the small groups and then bringing them back. Once you get beyond 40 students, it really helps to have TAs who are sort of also acting in that a similar, kind of assistant role. And so we, and in great big classes, we try and have, if there are 200 students, we'll have an instructor and 4 or 5 TAs actually to sort of support this. In the smaller classes, we just, we have the TAs in, and the different instructors vary in terms of just by their own preference of whether they have classes with TAs for, maybe 3 times a week, and then a 4th class is just the TAs, but they're doing much the same sort of thing, maybe more targeted to the homework problems. Other instructors just have come to all the classes and have TAs helping them in all the classes and don't make that distinction. There's no, haven't seen any obvious difference. They both seem to work pretty well and pretty equivalently.
I have another question, but it's about evaluating teaching performance, which I could ask now or I could wait, depending on.
Let me go through and let me come back to that, just because I'm looking at David's questions and there's some of them that sort of fit together and what I've already covered. And so I'll just kind of fit my answers in.
What you were talking about something when Miriam raised her question, but I had the feeling you were about to go into something else.
Yeah, well, so that was I think it's related to these. There's a couple of things. One is that was optimum class size. I was going to talk about that. And, what we find is smaller classes are always easier to teach. Just there's less students with, if you take 0.1 special problem per student per quarter, that's a bigger number if you have 200 students and if you have 5. But really the same basic, we've just found out how to implement these on bigger scales. And so we can implement them pretty much, I would say, up to 200, 250, we have, working quite well. So with, the TAs and just paying more attention to the details. But there's a question, so that's sort of an issue of class size. Beyond that, you really run into problems with the fact that it's hard to have a whole class feedback or discussion, because when they're teaching like this, you get a lot more questions from students. I collected a little bit of data, and for a while it was like a factor of 10 more spontaneous questions that the students were asking than in a standard lecture. But if I'm talking to 200 students and I have a student over here asking a question, it's really important for our, asking a question on something I need to explain. It's really important for the rest of the class to be able to hear that question and sort of be part of the class. It depends on the layout of the classroom, but in many classrooms I've seen once you get over 200, 250, then that breaks down. And so if a student on one side of the class can't hear when another student on the other side of the class has asked a question, then they're sort of left out, and then things bog down and don't work nearly as well. So that's again sort of a simple observation that when I check with lots of faculty, that's been their experience. But then there's the question about, should the traditional lecture hall go the way of the dinosaur? This is David's question. And, you know, there's no simple answer to that, because you're not going to wave a magic wand and convert all the university buildings into different kinds of classrooms. But I will say the modest adaptation that works best is to go to using lecture theaters, but having them rather low slope and terraced. And so the benefits of that is, on the terraces, it's easy for the students, especially the rotatable chairs, easy to work for them. It works in groups of 3 or 4. It's easy, especially if it's not a steep slope, for the instructor to wander up through those. But then also they have the advantage over a completely flat classroom filled with tables and chairs, and that it is important for the instructor to be able to talk to the whole class, and the whole class to be recognizing that the instructor is talking to them. And so in these big open flat classrooms, that can be a very difficult thing to do. Whereas if you have some sloping tier to it, then the instructor can be at the front and see all the students, and they can all see them. So that's kind of my suggestion for at least the evolution of the classroom. Okay, and then one quick question to answer is, how much time per week is optimal for this kind of teaching? The answer is nobody knows. We know, cognitive psychologists know, the brain can only focus really intently for a limited amount of time. It uses up some chemicals in there. And you can see, if you have students really seriously engaged, after about an hour and a half, their energy and attention really starts to flag, that they just are too tired of the thinking for that long. And that's also consistent with other things people have seen of how long people can focus intently. But what the recovery time is, and how you recover, and if you go from a physics class to a music theory class, do you reset everything? Nobody knows, and it'll be an interesting thing to find out as we go forward. But the current amount of time is just a completely arbitrary choice anyway. So any data will be relevant. Okay, so if there aren't any questions more on those things, I'll
I have
go
a
to
question
the
that's
evaluation.
I have a question that's a little related to that, which has
Yeah.
to do, you alluded to this problem of students wanting to use their devices. I wondered if you had any tips on best ways to deal with that.
Yeah, I mean, the best way to deal with it, or the way that I've found works best, and I've seen other instructors make this work well, is the first thing is, you just have to have, the main point is, students have to have something they are needing to be doing. And that gets to the idea of a deliverable, that they're going to have to write something out and turn that in, or they're going to be called upon to give their group to give a presentation, or they're going to be given a series of questions in the clicker, and that they have to be figuring out, so that they don't have so that's really giving them something they have to be doing, and so they don't have time to go look at their devices, etc. But that's a big step, but it's not perfect. There are some students who just are so conditioned to spending all their time doing that. And so, I mean, I and others have seen do this of just saying, you can't do this, you're not, and calling out students when they start, pulling out their phone when they're supposed to be talking to their group members. You just point out, no, you're not participating like you're supposed to be. You got to put away your phone. I've gone to the extreme of actually having to, when they're, and this is, a tiny fraction of students that I've dealt with. Usually simply telling people a couple times is adequate. But I've gone to extremes of taking away their computer, for example, because they weren't supposed to be looking, there's some things they're doing on their computer. Other times they're not supposed to be using a computer, and I'll tell them they should be putting it away and paying attention in class. And if they don't, then like I say, I've had to take away their computer during class, and that makes a big impression, so I could say. And similar with cell phones, but it's really unusual that you have to do that. Usually, if you just have things they're clearly supposed to be doing and you're expected to be doing, and they're getting monitored for doing, at worst, just a couple of comments is usually enough to keep that in line.
You don't believe, David's shaking his head.
Well, but it's this issue of making sure they've got something they have to be delivering, and they're accountable for delivering on it is really the big issue. And also, I mean, getting back to the question raised yesterday about different types of people in groups, setting norms, sort of community norms for how they behave in groups. And, we go through a little exercise where they do that because they always come up with the same things that I would, of what's good about, what makes a group good and effective. And that also really then helps, if you like, pressure students into, into focusing on the task, participating in the group interactions. Now, it's not perfect for everybody, but I think we've seen them make a big improvement over not doing that. Alan?
Hi, you mentioned accountability. I apologize if you said this at the end of yesterday. I had to leave for a meeting at 5. But do they get graded for what they do in the class? How does that work?
Yeah, so different people handle this in different ways. And I don't think there's any, my own feeling is some kind of accountability matters, but the details aren't nearly so critical. And so, but they do have to, they do get graded at some level on what they do in class. They have, a lot of times they'll be filling out, at least in the classes I've been doing now, they'll be filling out worksheets. And I have to turn in those worksheets. And in some instructors and smaller classes will actually do some modest level of grading. It's usually very modest because they're working in groups anyway. Most everybody's doing it. And other times, what I usually do is I just check off that, okay, they've written a bunch of stuff in the different sections, and then they get credit for having done that. But it is important that, and that they have to, there's some deliverable, and and the same is true for homework. And a lot of times in the homework, sometimes I'll have the working class, and many instructors do it this way, the working class will then be extended to doing the homework, and then so it'll be sort of classwork plus homework that they turn in, and they get graded then on that. Let's see, I was going to say one more thing about grading
You're
here.
thinking, let's check if Lolo or Marco specifically, or any of the students in the room have questions you want to raise. Get on the agenda.
Sorry, I have one question. Actually,
Can you hear her?
Barely.
can you hear me now?
Yes. Thanks.
So my first question is, you said before that there wasn't like that much use for recitation. So do you in your like setup here have a place for graduate students with like interacting with the undergraduates? Because I feel like for me and a lot of undergraduates, that was a very critical part of like the experience.
Yeah. Yeah, I'm sorry, I gave the wrong impression there. We're eliminating the recitation sections per se. We're actually having greater incorporation of the graduate teaching assistants into the teaching process. And it's just that at the most basic level, we're saying, okay, recitation sections weren't adding anything different. We want a recitation section that looks just like the other classes, that students are actively working together and solving problems and getting feedback. And so that's happening for every class meeting. And so one has to augment the instructor, one has graduate students participating in those class meetings. And some of those class meetings are taught entirely by graduate students. And so, yeah, so the students, the graduate students, I would say, are interacting probably more than they were previously with undergraduates. But we've also found, and again, this was kind of when we were running this transformation across many departments, it's really essential that the graduate students get training in this and get training. And they actually have been very effective at setting up graduate student training programs run by the graduate students then once they sort of have a model. And they're often kind of more into the more effective ways to teach than the instructors are, and can be kind of helpful nudges to the instructors to adopt more effective ways of doing it. But yeah, I didn't mean to give the impression that the graduate students are being left out. They're actually being more incorporated, and where people find this works best is you really have to think of not as here's a teacher over here and here's a bunch of graduate TAs over here, but rather there's a team that they're working together really on most aspects of the class.
Oh, thank you. And then my second question is, how do you recommend that instructors compensate for the like preparation difference for introductory courses, so that students that have less preparation aren't left behind?
Yeah, that's work in progress. Don't know how to do it yet. That's all I can tell you. We're trying to figure out how to make that work in as efficient and effective way as we can. And it has been a struggle, to be honest. You know, a lot of these students come in, if you look sort of the top quarter to the bottom quarter, it's can be 2 years of exposure to introductory physics. And, you know, how to have those students catch up in, you know, that 2 years in a, we'd like to be at as, you know, a quarter, or, you know, maybe it's going to be 2 quarters, but we're really struggling to figure out how to do it. Like I say, it's an experiment in progress now. And you know, we've tried to, our publications have tried to really draw attention to this in the broader university community as well, because I'm sure what would work at the appropriate standard isn't going to be the same at a lot of other places. So I'm hoping other people are busy working on figuring this out as well.
But before leaving this question, which is sort of super important, and I'm glad you brought it back to the forefront, what would you advise? I mean, you don't know the answer, but still, you've been thinking hard about it, and you may have some ideas. And you know, we have to do something, and you know, maybe I could imagine that a summer program would be helpful. Exactly how to pull it off is also highly not obvious. But
Yeah.
But anyway, please give us your thoughts.
So, okay, so I can tell you, I've thought a lot about this and I can tell you things that I think don't work. Okay, so first, remedial courses and remedial tracks don't work, where you say, okay, this is the dumb student track. And so, and I think, you know, those are all, in part, they don't work because they're designed around the basic premise that some students have talented physics brains and some students don't, rather than recognizing, no, these students just didn't get the education of those. And so I think some sort of thinking it more as a ladder where, okay, all the students are going to go ultimately end up going through the same courses, and there just might be some courses that are lower steps on the ladder that students have to go to if they haven't had the appropriate preparation in high school, and other students will be able to start a step up farther up the ladder, but then everybody goes up the same ladder. So that's at least, you know, the alternative to the remedial track, which like I say, is pretty clear doesn't work. I don't think the summer programs will work either. And the problem with them is they could in principle, but I just don't think they're practical. I think the numbers are such that the cost actually to scale them up, keeping in mind that a large fraction of the students who need this extra, you know, educational experience, they're low income. And so they're, you know, they got to spend their summer earning money to go to college. And so we can't, you know, so if you're going to have them go into a summer program, you have to not just pay for the cost of the summer program, you got to pay for the cost of what they would have been earning also. And so just from I can't figure out how to make the economics of that work for scaling it up to large scale. So that's kind of where my thinking is right now.
And time also, because the
yeah.
physics program is so packed that even if you don't have to sort of squeeze in a year of extra education, it's a problem.
Yeah, so that's a pretty easy problem to because frankly, you don't have to have a packed physics program. If you look across different institutions, the number of courses required and so on varies quite a lot, and it, you know, indications from graduate school are not that it doesn't make all that much difference. You know, the Stanford program, for example, it only has 3 years of undergraduate courses in it. You know, and no, and we're not seeing a lot of graduate schools turning away our students because they haven't had enough courses. So I think that can be is not that hard to adjust. The harder one to adjust, actually, that I'm worrying about is the engineering programs, because they're really all crammed in. You know, they all always want to have more and more and more courses required because, you know, engineering keeps progressing and there's new techniques and technologies they want students to learn, but they also assume the students have to have learned exactly the same courses those faculty took 40 years ago as well. And so that's where we're running into the biggest time crunch on the curriculum problem. But you know, that's a detail.
What about tutoring or extra sections?
So tutoring's another issue that in our analysis, you know, I told you we ran all these regression analyses and we find tutoring didn't help a lot. It's simple answer there. Now, you know, you could argue why it might not. And I think, you know, if you could say, well, maybe the tutors weren't very good. That's a possibility. The students really felt the tutors were valuable to them, but you look at their performance in the course and got tutors and didn't get tutors didn't seem to matter. There could be subtleties there, but I think it's more likely that it's just, you know, what we're doing is all these students are thrown together to cover the same material in the same time. And many of those students have seen that material much more. And so the limited time of the tutoring is just not sufficient to make up that difference. That's my current theory on it, of why we didn't see that it was very beneficial.
We have a question from Lauren, a graduate student,
Hi, nice to meet you. Yeah,
and then Marco.
hi. So I had two questions actually, but maybe I'll ask the shorter one first. So I've heard you talking a lot about the types of questions you ask students being like with clickers and multiple choice and that sort of thing. And it seems sort of counter to what you're saying about how students learn to make it sort of a discrete choice sort of question. And I can see how that would be more useful for the metrics that you're trying to take, but do you think that that's really the best way for students to be measured or to learn?
No, and so I'm glad you raised this question, because I can be clear about this. What we have students doing in class are not answering questions like that. They're actually making these kind of decision questions. What concepts apply in this problem? What information would you need to solve it? Can you make what's your plan for solving? When they get an answer, give a justification for why this answer is reasonable. And so these are much more complicated. The clicker questions are really just things that, first they accomplish two purposes. One is, if the student knows, those clicker questions are just a way to monitor how they're doing on those longer answers. So they'll just be picking out a little piece that you can check, okay, they got down through that part and they understood that part of the solution. So you can think of it as just a sort of brief check-in that they're doing. And it also sends the message that we're going to be monitoring that if you're actually doing this activity, and which in a class of 50, I don't have to worry about. In a class of 200, I do, of trying to make sure everybody knows that they're going to be doing something, and I'm going to know what they, as an individual student, did. So that's a big part of the clicker questions. Think of them as pragmatic proxies for a deliverable and a monitoring, brief monitoring of how students are doing. The other aspect of this, though, is that you can make much more complicated clicker questions than what people are used to, and which I tend to do. So, first, with technology now, you can have where there are 12 possible answers, and students have to pick the 3 most important ones, okay? And so where they all have some relevance to the problem. That requires a great deal kind of more thinking than what, which of these 3 numbers is the correct one. So you can have actually much more deeper questions that you can ask that way. So, but anyway, that's sort of then the next level of detail. But in most of these things, the clicker is just this kind of short-term check-in of things that they're doing much more extensive writing on and discussion.
Thanks, that makes sense. My other question was, I was wondering if you think there's different methodologies that would be more useful for teaching non-major classes versus major classes, or undergrad classes versus graduate courses. Like, the difference to me being like, are the students there really invested in learning physics, or are they there because they're fulfilling a requirement? Things like that.
Yeah, so I think I'm become actually more and more convinced as if we've gotten more data on different ranges, that the basic principles all apply, but then, how you implement those principles is different from different in different ranges. Now, speaking for physics, let's take undergraduate physics majors classes up through graduate. There, the distinctions we see are pretty darn small. I mean, we now have this kind of template for a class, and we've applied it quite effectively from the first introductory level, or maybe second, because it's physics majors, really up through the most advanced graduate classes, and it's not so different. The ones for non-majors, and there's kind of the engineers, and then there's classes for just non-scientists. They're I'd say the principles still apply. Those, in my slides yesterday, those boxes are, each of those boxes is still relevant, but what goes into those boxes, and particularly the two on top, which were connecting with prior experience and motivation, those are very different. And in a course for non-scientists, for example, or non-physics majors, one really needs to pay quite a lot more attention to those and the design to motivating the students, trying to convincing them it's interesting, helping support them to understand how to learn. You need more attention to that than you would in a advanced undergraduate class or physics, for example. So, but nevertheless, in any level, any course, you still do have to pay attention to what's in those boxes and what we know is important in the research, what those tell you.
Thank you. Marco?
Yeah, I wanted to go back to your comments about tutoring, one-on-one tutoring for a second, to make sure I understand. So there's this really classic result from Bloom, right? That one-on-one tutoring, students who go through one-on-one tutoring perform 2 sigma better than those in the traditional classroom setting.
Yeah.
So I just want to understand, like, are you saying that result has been disproven, or tutoring it's not useful when you've already implemented this stuff, these kinds of programs you're already talking about, or we just need more time one-on-one tutoring? Can you add a little more nuance there?
Yeah. So first, and I was just thinking about this because I was explaining it to my graduate students. I actually went to the trouble of digging into what was behind that claim of the 2 sigma benefit of one-on-one tutoring. And basically, there isn't research that really justifies that at all. But there is, I think there's plenty of reason to think and to believe that one-on-one tutoring, or if you like, I could call it the master apprentice model, is effective for human learning. You can see we kind of evolved to learn from some a parent or whatever or expert. But then you need to look at, but then it's helpful to look at, okay, what is a good tutoring really doing, a good tutor really doing, which Bloom stuff didn't look at that at all. And that was one of the big failures of it. But, and he also didn't say that he changed the curriculum between the control condition and the tutoring condition, which is a little questionable as research. But if you look at what happens in studies of really highly effective tutors, what you'll see is that essentially they were doing all the things I'm talking about are valuable for the design and implementation of the teaching practices. And so, what I'd argue is that to a large extent, all this is doing is finding ways to build in the cognitive tasks and cognitive supports that are that are present in a good master apprentice or individual tutoring model, building that into the structure, scaling it up to the classroom with one-on-many compared to one-on-one, but trying to capture as much of the value of that one-on-one as you can get. And I would say that actually the one small addition that we put into that is we do build in this idea that there's working in small groups, which in some master apprentice things, the apprentices work together and learn from each other. So that's not that different, but the social learning aspect is also added and valuable to that. So.
Maria had a question.
So in the limited time we have, I want to also switch a little bit to discuss institutional change. Since you have a book on it too, but
Put it on the agenda and then he can figure out how to
okay.
work it in, because he also has maths too. So.
Okay. So whenever, I think that's also an important aspect. I think Matt might be interested, especially for faculty, right? We have basically no training really before we start actually teaching. And so I think that aspect where it's, having incentives to, institutional incentives to actually to put in the time to get training, as you mentioned, this beautiful website you have. So anyhow, I'd be interested to hear that whenever you feel comfortable or appropriate.
So this, I think that the training here is something I think is very closely linked to the question that I didn't answer before. I think Matt asked about the evaluation of teaching. And where I come down from now is that we can now define expertise in teaching. And, it's represented in my figure with a bunch of little boxes. And, there are things you need to know about what kind of tasks, what goes into the task for that, how to motivate students, how to, appropriately deal with the brain constraints, the social learning and feedback that we know will optimize learning. We have now lots and lots of evidence about this. And so we need a teaching evaluation system that measures how much people understand and are applying those ideas. Now, as soon as but you can't put in an evaluation and incentive system into something where nobody knows how to satisfy the criteria for the evaluation unless you also build in the training for it as well. And so I see these are really things that need to go together. And it's not, I have training, I developed training programs for UBC and now doing some of it at Stanford. And it's not that hard. If you're familiar with the expertise research, they would say, okay, you need something like 10,000 hours of practice to be a skilled physicist. And what I think we've found from our program is it takes maybe about 50 hours. Once you know the discipline, it takes about 50 hours to become a reasonably skilled teacher, 50 hours of training and practice in these, most effective research-based methods. So 50 hours is per faculty member. On the one hand, they probably spend that much time in faculty meetings per year, so it's not enormous. On the other hand, it's certainly not trivial either. Few of us think we've got 50 spare hours. And so, that sort of needs to be built into the system, I think. I think once many institutions are starting to adopt better teaching evaluations where they're really measuring, okay, are people using these better methods in their classrooms? Then in fact, it's going to be kind of automatic that graduate students will have had a course in that, because they wouldn't get good faculty positions otherwise. And then it won't be nearly such a problem. It'll just be the same way they need to learn about, quantum mechanics. But the transition is going to take a while, and it's going to take some significant investment, but not overwhelming investment, I think is the answer.
Nice. I have another question, and I was just wondering if, with all the research that you've done on this, if you've considered for underrepresented minorities, even if they are, caught up with the topics and are doing okay in class, the impact maybe like not being represented with their students, not being represented among the faculty, and just like in physics in general, not seeing themselves reflected in like who is doing physics and who's doing well in physics, even if they are themselves doing all right in class, if that will have any effect on if they stay with the track or maybe their performance in the future.
So this is something that I haven't studied. I'm aware of the research on this and the learning of it, and different things that people have attempted to intervene on this. And I know there certainly are some programs that have been very effective at this. There's a biology scholars program at UC Berkeley, which has been really effective at getting students essentially so they just feel comfortable pursuing and not kind of left out, pursuing advanced degree, a major to go on to graduate school in biological sciences. And, there's a few other things like that. I haven't seen anything where I was convinced, where there's good data showing that there was a significant or substantial impact within what one does in the course and the instructional practices, other than there's a bunch of stupid things people can do, what they say about students and what expectations, and so, stupid and offensive, and, tolerating other students saying offensive things, that, obviously getting rid of those is important, but dealing more generally with these kind of social and psychological things, it's clearly important. People are studying it. I don't think we know enough yet about how fully it plays out at the undergraduate and advanced undergraduate levels. But so that's all I can say. Other than good, in general, good teaching methods seem to help everybody, and they usually help the marginalized students a bit more. On a fractional basis. And you can kind of see why, because there's a lot of, feeling like you don't belong, other people are, if you're from marginalized group, you don't belong, everybody's smarter than you. This is a very common sort of sentiment of college students. But if you're instead of being isolated on your own because there's nobody else who looks like you and you're sort of feeling separate and so on, it's clearly different than if you're working effectively as part of a group, and then that makes you realize, oh, I'm not so different than everybody else. They're all struggling in the same way as I am, and I'm learning as much as them. That clearly does provide some help, but I won't claim that it solves the problems you say in general. But I also think those are probably quite dependent on the institution and the student population, and that's a place where we just don't know enough to have good prescriptions yet.
So it seems to me that a lot of the methods you're describing are the approaches that we would take to train students to play musical instruments. I was wondering if you're a musician. Do you play a musical instrument?
I don't play a musical instrument, but I've read this. Anders Ericsson has done a lot of research on the development of skill at playing musical instruments, because this is a wonderful test bed for looking at the development of expertise. And so that, in fact, was the most revealing, was the place that was the most revealing about how expertise was developed, and then kind of went on from music to show, okay, the same thing's happening in a whole bunch of other areas in how to become more expert. And so there is a clear relationship here, but yeah, and it just shows up better in music than in many other areas. It's just easier to identify the pieces, the best teaching techniques, and so on. But it's I'll just amplify on that. You know, people can teach music now vastly better than they could, 200 years ago. The music's the same, but the student learner nowadays is vastly, would be an incredible master back 200 years ago, just because people found more effective ways to teach, and much reflecting, or much of the things I'm talking about are reflecting those advances in music teaching.
Hi. Thank you. My name is Kate. I'm a grad student. My question is actually a bit connected to David's question. It's about evaluation of the students and testing practices. It's another model that you might think of as like the flex school model, where all the students either, if you want to keep going and keep at it, you eventually pass some bar and are able to be a physicist, whatever that means. Versus I think the current model of testing kind of keeps people regimented to have to be following along at the same rate or fall behind and fail out to some extent. And then there's also the issue of examinations, maybe just not being good ways of measuring how good you are at physics or how good you will be at doing physics as a career. And then the mental health issue about examinations in college and the pressure we put on them adding stress. So I just wanted to ask you to comment on all of that.
So those are all really important issues, and I'm glad you brought this up. This gets to the point of the issue of grading in general. And so we know a number of things about grading that are important. The first thing I'll say that's kind of most fundamentally important is grading on a curve is bad, because all the things that I'm talking about here are really kind of how to use students to leverage their own learning. And if you start to grade on a curve, basically you don't reward somebody for mastering the material. You reward them because they just did better than somebody else. And so if they can hurt somebody else's learning, then that's easier usually than learning it yourself. So grading on a curve is a really bad practice. The other thing, and that gets to the issues you raise, is that frequent low stakes grading is much more pedagogically effective than a small number of high stakes exams. And it's even better if there's ways to, like the things you talked about, of going back and fixing somehow, getting some more credit through going back and looking at your low stakes exams or in your high stakes exam, looking at what you did wrong, explain why that was wrong and how you could do better. And so that's, helping learning, as opposed to just, the worst case is you don't do any feedback or any assessment until you have this final exam, and then you either pass or fail. That's sort of no good at all, because then it's just about guessing what's going to be on the exam. It's about dealing with the stress, and it's very little to do with actually the measurements of real learning of the material. So yeah, so the main thing I would say is we know research is don't grade on a curve, have frequent low stakes assessment that gives feedback to the instructor and the students that they can act on to enhance the learning. Yeah, and then I guess the other thing is to recognize how little exams really measure of what you care about. I started out my talk yesterday trying to emphasize the brain learns what it practices, and the cognitive practices, their mental practices in answering the kinds of problems that are on the usual exam of, here you've given all this information and just the information you need, and you got to apply it into some procedure to produce some answer. That's so different from authentic scientific problem solving that those kind of exams are really bad proxies for measuring what we really care about. And they're really just a historical artifact in the same way that bloodletting is a medical artifact, and we just haven't gotten beyond them. But they're really, they're based in this fundamental flaw about learning, of thinking that it's mostly putting information into these fixed brains. And so because of that, you can say, well, I can give a test that tells me how good the brain is. And so that must be equivalent to telling me how well it could be as a scientist. And that's just wrong. They're just quite disconnected phenomena.
Thank you.
Can I ask a quick follow-up just on grading in more of like a nitty-gritty sense? Can you comment on grading on other things or things that come into grades very often, like grading on attendance, grading penalties for late work and these kinds of things?
So yeah, I mean, I can comment on it. I'll separate my comments out from what I was just saying before, where I can point you to research studies showing that frequent low stakes assessment and opportunities for feedback produce more learning than a few high stakes exams. Okay, now that's what the research says. Now I'm going to switch to the particular grading choices are, they're very much a matter of personal opinion. And so my personal opinion is, having looked at what exams really measure by even in other people's cases, or in taking some of my own students and then doing in-depth interviews with them after the exam, I'm convinced that they're measuring so little that matters, that I think I'm doing better if I just give grades. I'm likely to be more valid by just giving grades for students doing everything that I think they should be doing to enhance their learning. And so that means I give little pieces of grades for a whole lot of different things that are important for the class. They have preparation for class that they get a few points from. They get what they do in class, and working through the work in class is worth a bunch. Doing homework is worth a significant amount. These various low stakes exams are worth some. Then I have going back and anytime on either the exams or the homework, going back and explaining, looking at what they did wrong, explaining what they did that was wrong and how they can correct that. They get a few more points for that. So there's probably one or two other things. And I found that basically students do everything you give them points for. They're not, especially when it's so many categories, they figure, okay, he's giving me points. That says, this goes my grade. That tells me it's something significant. And if they're not grades for it, they just don't do it. And this was a very long time ago, an early but very informative experiment that I did, which was that I had students prepare a reading before class and give them these little quizzes they got points for. And I did a survey halfway through the class and everybody said that, this preparation for class was really helpful for their learning. So I figured, okay, I don't need to waste their time and my time on giving them quizzes on this anymore, because they've all agreed it's really helpful for learning. And as soon as I did that, almost everybody stopped preparing for class. And so I asked them, what's going on, right? And they explained, well, grades are what matters. And if you're telling us we don't get grades for this, we'll go spend that time doing something else in some other class that is graded. And it made me appreciate how we've conditioned, so this isn't their flaw. This is that we've conditioned these students through 14 years, and we selected them carefully to get into our, universities on the basis of what kind of grades they got. And so, we've conditioned them that grades are what's important, and that's really largely the only thing that's important. So, okay, so I figure if that's the message we've conditioned them on, I should give them grades for everything I want them to do, just to be consistent. But that's, like I said, that's my own opinion. No research showing it's right.
I can push you on that point a little bit. You say you want to grade them on all the things you think are important. One thing you emphasized today and yesterday was that you think phones are a big distraction. So would you penalize for use of phones?
Yes, I would. I mean, on that, I don't actually connect it with grades directly. I connect it with immediate, feedback of stop doing that. And when they don't stop doing it, I take away their phone. But yeah, there's certainly a message. I send a pretty clear message on that.
We're starting to wind down on time, and it's been so wonderful, but I want to give Matt and Miriam the last chance to ask a question if they have one, or unless there's something you want to say.
Yeah, and I think this is Matt's. I think Matt asked me a long time ago about or somebody asked about the evaluation of teaching. And so I'll just say a little bit there, which is that the student evaluations, they don't correlate with measures of learning. They don't correlate with measures of effective teaching practices. And so my group developed better ways to do this. And so we have something called the Teaching Practice Inventory, which takes faculty 5 or 10 minutes to fill out for a course, but really captures almost every teaching practice decision they make in the course. And so it's, not just what they do in class, but it's their grading policies, their types of exams, their how they use their TAs, and all these things I've been looking at, so that you can much better characterize this and see to what extent. So it characterizes how the teaching is being done. And then you can see to what extent are they using these practices that research shows are more effective for learning. And so we have that teaching practices inventory, and then we have something called COPUS, protocol. Anyway, it's a class observation protocol, just to kind of check how students and faculty are spending their time in classes. And then there's some other things one needs to worry about of getting away from student evaluation questions that are highly biased, like how good is or sensitive to bias, how good is the instructor? Okay, turns out in a science class that depends a whole lot on whether they're female or male, and various other things like that. And so questions that are important are capturing the student experience where they're uniquely capable of answering it, but not answering questions that they're not really qualified, like, you know, did you learn a lot? Well, you know, the only way you can know if you learned a lot is to know what you should have learned that you didn't, and so no student can answer that question credibly. But they can ask questions like, did they feel comfortable asking questions in class? And you know, things like that are important, and are important in their education, but they're also uniquely qualified. So I would argue that having an evaluation system that captures those kinds of things, and therefore quite different from our current system, is really what one needs. And as I say, there's this AAU STEM initiative program that has a call for proposals to demonstrate such things. And it's got a list of criteria of what those proposals have to address, and covers the things I was talking about and some more. So
Thank you.
So perhaps one last question. So it's a little bit different about graduate education. So you mentioned something about assessment, right? So physics GREs have been required, geophysics tests. What are your thoughts about how useful that is for graduate admissions in physics?
I think, again, it's just it's dealing with a completely flawed concept of you know, the brain and how it learns. And I think how you do on GREs has very little to do with how effective a physicist you'll become. So yeah. Now, you know, again, you look at, okay, what's involved in thinking to do well on a GRE versus doing real physics problems, and boy, do they look different. So how people did in undergraduate research is probably a much more meaningful comparison, actually, than any test like the GRE. And
It's
I
a
actually
highly contested question during faculty meetings. Thank you.
So, you know, that people are starting to look at the GREs now and so on. I actually look at the MCATs, the medical school things, just because they've been studied more. And, you know, there's a reasonable correlation between how well people do on the MCATs and how well they do on their first medical school courses. But there's no correlation at all with how they do as doctors. And, you know, that makes sense. There might be somewhat of an anti-correlation because, you know, the thinking you got to do as a doctor is just not what you do to answer a multiple choice MCAT test. So.
Thank you.
Last question. Well, I would love to get to ask more questions, but this is just wonderful. Maybe we all work hard and read some of the things you sent to us. I already read a few of them. There's a wonderful one from Peter Lepage about the, I guess we should look this way when I look at you. Anyway, about applying it to quantum field theory. I didn't get to read it, but I downloaded it. It looked very interesting. And then one of the people in the audience yesterday sent us about debunking the learning styles things was wonderful. So anyway, maybe we'll be able to send you more questions or get together again in some amount of time.
Oh, one thing we should remind people, Glenn, so just before this started, Glenn and I were talking about videos of class is run this way. And for complicated legal reasons, it's kind of hard to get good videos. But if you go to the CWSEI website that I was showing and you poke around, they changed this. It used to be on the homepage. So you'll have to poke around a little bit on it. But there are a bunch of videos. These are primarily in larger science classes, but they will give you some examples of in these different kinds of classroom settings, the way an instructor's working in the class and the way what the students are doing. So
that would be wonderful. Thank you so much.
Thank you so much.
Thank you very much.
okay, bye.
Thank you so much for your time.
Yeah. So now that we're off official, what were you